changes of density go away for certain wavelengths. Very interesting problem. This is what the hackathon is going to try to start solving. And again, because it's such a simple thing, if you ask the average person that, well, electricity is light, metal just has a special property, we're pumping it up in pulsating ways and creating densities, and it's shooting out densities and goes out to the world. And we can even think in physically it's coming back at us, we're interpreting, it's just density changes. It's like literally almost like sound waves. So this is, the reason I think this hackathon can work is because the average person can grasp this stuff, right or wrong. I'm calling this the new string theory, because the string theory was completely invented. And the people today are just abhorred. At Cal State, when we were living in California, the person got in the LA Times and said, they asked the original guy, says, what do you think of all this? He says, I am flabbergasted. I feel extremely upset. He said, we invented strings knowing they were invented. It had no physicality. It was just an exercise. Now these guys think it's real. So I think we may have the opposite going on here. So who knows? Anyways, that's one of the things in the hackathon we're going to try to do. The universe is digital. We think of the universe as analog. The new model of gravity and light made me realize this universe is digital. Mass is in motion. Is a unit or digit, I don't care. Eventually they're called
particles.
Unicosms and microcosms. Basically, neomechanics says something very simple, but it's very profound. We are, I'm at this level. Everything above me, outside of me, affects me. Everything inside me that makes up of me affects me. So it gets very complicated. But eventually, like I was saying with Duncan, we can disagree that there is no more particles down there. But we can talk about that one and be happy, because we're never going to be able to talk about everything at every level. This actually, to model this universe that my father has in digital form, isn't that hard. I will tell you something crazy. If you guys, or anybody in here, are up to modern gaming, you could hack the universe in Minecraft. Because you could use those little squares and model stuff and move them with time. You've got the universe, moving mass. Anyways, okay, metal and ether. That was my original paper until I realized my dad became famous overnight and I wanted to put my name on it. And even though when we're gone, they'll probably say, Dave had nothing to do with it. He just wanted his name on his paper. And even if this all is not true at all, I ended up putting my name on that. But here's the reason why.
If it's bad, it's Dave's fault.
I'm sorry?
I said if it's bad, it's your fault.
Exactly. That's totally cool. You know, I always thought, here's one of Dave, I have a lot of sayings I make up in life. One of them is, taking blame takes no energy and no effort. If I'm in a meeting, someone says, that's your fault, David. I said, that's fine, you can blame me all day long, because I don't have to do anything. You just talk about me and say, oh, mode and all that. And I said, yeah, that was me. So I'm going to show you one of my wow moments here. Do you want to continue? Yes. Yes. I'm sorry. I hope we don't have to watch an ad. Yes, we do. I think there's music with this. But I will tell you, if I remember, it was so horrific. I think it's 10 times better without it. Yonel Benu is a brilliant physicist, but he is not good at selecting music. Maybe it was a Romanian folk songs or something. There he is, the man himself. Okay, what he's doing here is he's going to show the behavior of two magnets. Of course, no one needs to know, explain what's going on. Those are attracting, and again, these are two metal magnets hanging.
Bottom left-hand corner.
What's real important is to look at the behavior of these things. So you can imagine if it's ether, and ether is flowing in this direction, and metal and ether have a special relationship. That's what I contend. I think we need to look at metals and their structure atomically to find out why they are so special when it comes to ether or gravitons, or whatever you want to call it. Now, he had done some other ones before where he had a kid's pool, had water in it, but this is his different one. So these are two cylinders, they're spinning underwater with weights just to keep them down because they're wooden. So you see they're like moving around, bouncing around. He's doing the right-hand rule. I tell you, I don't know, I still don't know how he did the experiment. This is a tough thing to do. I mean, to spin cylinders underwater. Of course, you know, the idea is the water represents ether. You can imagine he is a person, he's an etherist. I think he got his cue from Romanian cinema. They hold on to stuff too long. I'm saving you from his soundtrack. When you listen to it, you'll thank me. So there they are, spinning in opposite directions. Attract. Different direction, or same direction. Oh, no, they're doing opposite. Yeah, that's what he's showing.
This is fast.
Yeah, that was the same thing. That was the same thing. He was just showing touching so you could see the rotation, I think.
There are motors inside.
You're going to ask me about the physical setup? I don't know. I think that's what I'm
That's
guessing.
the whole point, that he has motors that draw water through.
No, he's spinning well, he's doing spinning. He's not drawing water through them, no. These are, the only thing that's happening mechanically is they're spinning, that's it. And he has them isolated so there's no flow, it's not a pump.
That's a good question.
And I think that although they're spinning, they're not throwing water at each other or away from each other, but I do think they're causing some rotation of the water around them.
Well, that's the whole thing. What this is real simple. What this is showing is that rotating liquid around these is going to be modeled in the real world as ether whirling around metal. That metal has some property that makes ether go into whirling. Now, when we talk about gravity, or let's call it, like my dad calls it, gravitons. Gravitons, one, are going round and round and round. Well, for them to go around, it works in water because they're all sitting there and they're all in a space and there's repelling going on. You can't, it's going to be the same problem as the stars. If ether is whirling, they should be flying off. There's no reason they're whirling. They don't have strings attached. They're not holding hands. So, according to Borkert, neomechanics, every level you have to have, for anything to whirl around anything, you have to have a smaller particle that's a field. Gravity 2, ether 2. That's if you believe. It takes a while to think about, but think about it. It's really the only explanation. If you really believe there's mass in motion, that's all you have in the universe. Okay? I think you guys got the idea. You can listen to the soundtrack at home. Okay. Alrighty. So we talked about electricity is light. Metal has the ability to change ether flow. That was my paper until my dad came along and ruined it. No, I'm kidding. And metal channels ether and wires. Robert Berger, we're already hacking it. We're sitting at lunch at LexisNexis, and he comes up to me and says, I don't think I need ether 2 to change the path of ether 1, or gravity 1, gravity 2. He says, if I have an idea that the model of an atom is like a disk and it's rotating around like a fan, and then if I have all this lining up, that would keep, things flowing. It's already, people are already hacking it. People are trying to come up with mass in motion, what are the properties of mass in motion. There's not a lot, but the variety is really amazing. So what is it? We know these things are going on. Ether and wires. Why is that happening? What is this in the structure of atomic structure? What keeps that going together? For us to know how and why this experiment with Yonel Deneu is really a model for electric fields, and we know that ether can't move on its own, we have to start understanding, therefore, ergo, the structure of atoms to explain this. If we know metal has a property, that is, if I put an electrical current on this table going across, it ain't doing well, but if I do it on a wire, it's doing great. What is it about that? That's, of course, assuming that light, gravity is, electricity is ether or light or gravitons. What is it about something? And that's where the ether 2 comes in. So that's where you're getting that. You got to think about it. Give yourself time. Okay? Lasers. Of course I thought, well, look at this. Dad was talking about it. I don't see anything here. If I put my hand there, I see it. Why am I only seeing it there? Why? This is a phenomenon nobody in mainstream science can explain. Lasers. We use them all the time. In fact, modern life without lasers almost doesn't exist today. But if you make lasers just a bunch of gravitons or ether going together in space, right next to each other, all together. And, oh man, I can blow holes in stuff. Why? Because if ether is the thing that pushes and causes gravity, sure, you put a bunch of them together, you're going to blow holes more powerful. We have an explanation, a model for it. We just modeled something that we didn't have a model for. Why can't I see it here? Well, because they're all flowing in this direction. If there is some incident of it coming off and you seeing it, you're either seeing it because at night they put smoke. I know, I've been involved in shows. You will put smoke there. You're not seeing the light. Well, why is that? Because when it hits that surface, it's spreading out into 360 degrees, well, in this case, 180. Just go, it sends all the ways back. But we have an explanation for it. Dad's talked about refraction, colors, reflection. The redshift is the redshift in everything we see. Is it just because these particles are traveling and they're hitting things and bouncing? And I don't know. What is happening? Redshift is the density change. Is there a density? Is it maybe it's the interference of particles at the lowest level? That is, if you just shove particles in all directions, you're going to get an interaction, and then the redshift is this, just the random interaction, whatever the calculations my dad comes up, because everything he says is right. I'm his son. Okay. Actually, folks, if you want to know something, I am the exact opposite, because in my film, you can see I was agonizing over the fact I threw my dad in the middle of these people who had been doing this much longer to do this experiment, and I felt very, very guilty about it. So I'm actually the opposite. I don't want to build it up, but it's he came up with some pretty neat ideas recently. Okay, this is Glenn Borkus again. I talked about space, mass and space, mass and motion, infinity up and down, only pushes, and also mass and motion can't have one without the other. All mass is in motion, and you can't have motion without mass, motion. Other thing that Glenn Borkus says, which is an interesting thing to say, to think about time is motion. Okay, if you think about that, it's interesting. So that gets us to the hackathon, and if you're not into the internet recently, there are things called crowdfunding. Before my film, they didn't have crowdfunding in my film. I actually did crowdfunding by snail mail. It worked, but I can't believe, I looked today, I said, it's so much easier. You want to film, and everybody in the CNPS wants to support it. You don't send out letters and then videos. You can just do it over the internet. Well, they have crowdfunding. We have hackathons. They hack different things. They'll have a hackathon. A hacker is a person who goes in and messes with code. They mess with the system. Well, they'll do life hacking. So now it's become I'm a linguist, and we look at words. It's become like taking things apart, examining. So, University Hackathon. Our meetups have not been really popular. Once or two or three people show up in our CNPS. I put Hackathon on just last week. 4 people signed up? I go, oh, I'm not going to be there. Put Hackathon. I put it out here. We have some students coming in. They see the Hackathon. There are simple rules based on mechanics, like I said. Look at the antenna. Electricity is light. Well, why is it light? Well, electrons in metal are supposedly going at meters per second. Why is, if it's going at C, then it must be related to C. They get that. It's actually simple to model on the computer. I can see that happening. It allows for multiple models to compete with each other. Who's to say that's right or wrong? We have meetups around the world. First public hackathon is going to be on Saturday. What is it? We need to start using these same things. We know what fields are. Fields are mass and motion in general, in random velocities. We get gravity because of the things that get close and cause pressure differences. How is this going to relate to everything? The other thing I didn't put down here is one of the things I'm trying to convince Glenn Borkert, and that is, in these levels, we are in this level. A level below us is the ether or gravitons. A level above us are the planets, and then we have above the stars and planets, we have galaxies. Actually, if you read the universal cycle theory with neo-mechanics, they propose a superstructure that is made out of galaxies. So we have all of these things. Why is it then, from our level to the atomic level, why is that so organized? We are not atoms. I'm not with Musa, and I'm not with Duncan and my dad creating a boron atom. It's not happening. It's very, very, very varied. So my thesis about the infinite levels is that when you go from level to level, you're going from complexity to diversity to stability and back and all that stuff. Not necessarily even, but it's probably true that you'll need a stable level to create variety. Now you're getting into really some interesting things. And these, I think, things are that the average person can talk about. And these are some of my ideas that just spawned from my dad's work with with this one idea that light and gravity are the same thing. It's just that, you know, it's come up. Dr. Lucas talks about it as being the leftover electric force, and that it all comes. The reason everything is attracted to everything because it's an electrical force. The only problem I have with it, and everybody else who's sort of in my boat, is I don't want to hear the word field ever. I don't want to hear charge. Charge is there, yes, charge, but I want a physical manifestation of it. I don't want to call it just an abstract thing. We need to start making these real. So as much as I really admire, and I do, Dr. Lucas's work, and the EU people have a lot of interesting things, Electric Universe. They talk about fields. I said, what's a field? And that's one thing I just cannot accept, and I will not accept. And that's what the hackathon's about. The hackathon is, there can't be a field. There can't be this. Oh, I have spin. What's it like? No, it's just spin. No. Spin could be, in reality, have nothing to do with rotation at all. It's a property we put on them. We didn't measure electrons. We didn't put a point on an electron and say, oh, what was his name? He won the Nobel Prize in 1933. He was 33 years old. Davidson, I can't remember. Carl Davidson, or I don't know. He won the Nobel Prize for the positron. Oh, because he puts it in, and one goes this way and one goes that way. Oh, it must be spin. They just made it up. Did they mark it? No, actually no. I had a marker and I marked all the little electrons on this side, and they were going this way. We have to start admitting this and understanding that. When I talk to people, they get much more satisfied, the average person who doesn't know about physics, when I talk like that, because they're, they go, oh, I hear spin, I hear, oh, what's charm? What's color? What's strangeness? It's a bunch of baloney that you make up. You make up your system just like, who was here, he's not here now, the guy who talked just before noon, he had that guy talking, yeah, we go over here, and if it moves over here, we call it something different. We're tired of it. I think the public is tired of it. I'm tired. If you tell me there's another electric field, and the fields attract, and you don't tell me, oh, the fields are made of these moving masses or forces, and don't talk to me. Don't talk to me. I don't want to know. So that's the kind of attitude. You got to almost be radical in that attitude. So we're hoping, my hope is that it's so simple, even if it's wrong, even if it turns out to be the string theory of our day, at least it gives us principles that we can agree that aren't magical. That if it's moving mass and that's all we have, everything from now on in our hackathon, that's the rule. It's got to be moving mass. If you say, well, this whirls around that, you're going to say, okay, there's an ether too. Got to have it. Got to have it. As long as you know that, that's cool. But we'll see how the public will react to that. So that's it. Thank you very much. No questions. No questions, right? What time is it? 2:15.
Just some
Yeah.
small remark.
Sure.
In fact, all is okay, but just small remark. We are able to measure what is connected with quarks, so it's illusion, but we can measure the thermal precision of particles, electrons, also this could be, but another part is absolutely true what you said.
Yeah.
Just one small remark, we really can measure the speed. We can measure the level.
Okay, it could be.
For some particles, very small sound.
Right. I think the frustration comes when we can't even say, I'm writing an article right now. I haven't got out because I've been so busy. I told a few people here, but it's in a letter to an alien who comes to our planet. And it's a great long apology for all the stupidity we have today. You know, yes, here's the most complicated machine on the planet sitting here, and what is it? It's a hammer. Basically smashes stuff together. And how do you see what you're, no, well, you only see the trails of what's there. What's the shape and size of it? How do you know? Well, no, the rules are is if we hit it harder, we'll get to the next particle. And then I'll have to say, no, the rule really is when we hit it harder, we get to the next Nobel Prize. That's what we get to. So it's really sad, and it's really wonderful here. And that's why probably one of the reasons I was asked why did I go through, and my family went through, a lot of hell to keep this organization going. And that's the reason. It's, you know, I think I couldn't have lived with myself knowing that this is out there and the people here are talking real science. And a number, Duncan, Nick Percival, other people supported us as much as they could. And this is the only place in the world, folks. The only place in the world we can do this. So, any other questions before we take a break? No? Thanks so much.
Thank you.